Welcome back to the Non-Participation in Surveys, a practitioner's guide to the conceptualization, impact of, and adjustment for unit non-response webinar. My name is Pamela Woitschach, and I'm a postdoctoral researcher at the BC Office of Patient-Centered Measurement, BC Support Unit, and at UBC Paragon Research Initiative. In this series of 3 webinars, I will be accompanied by Dr. Bruno Zumbo, professor and distinguished university scholar. To cite this webinar, please follow this example. In this part of the webinar, we would like to thank to Dr. Beth Griffin from RAND Corporation for her support and advice in the use of the Twang package. We are now in part 3 of this series of interconnected webinars on the topic of unit non-response. This webinar part 3 will be focused on the tools to adjust for unit non-response. In this part, we will talk about imputation and weighting as tools to adjust for non-response. To remind us of most of the important concepts, we will begin with some information from part 1 of the webinar. We will define unit non-response and what adjusting for non-response means. In the next section of this webinar, we'll be talking about one tool to adjust for unit non-response, and a demonstration of its use will be presented. Long ago, when I started this project, the problem was presented as a representativeness issue. Then, after some readings and meetings, missing data appeared as an important part of the problem. As a measurement specialist, missing data was not something that new. The last few years of my career, I've been working on complex designs analysis in large-scale assessments. In large-scale assessments, large-scale assessments often acknowledge the presence of item missing data and tend to ignore unit non-response. Several background samples are often included to address lower response rates, but no adjustment is done on the designed weights to account for non-response. Unit non-response is a phenomenon that can be analyzed from different perspectives. As we stated before, it can be seen as a representativeness issue or a missing data one. We can also talk about non-participation, or we can classify it as a partial total non-response or unit non-response. One can say that non-response is due to the way questions are made, the extension or topic of the questionnaire. Also, we can say that non-response is due to the lack of the interviewer's ability to interview or to engage with participants during the data collection. It can also be due to the willingness of the participant to respond to our questionnaire. There is a cognitive, emotional, and cost-benefit analysis underlying the participant's decision to respond to our survey. Despite the survey questionnaire and participants' relationship with them, or with our survey research, non-response can also be due to an external factor that can lead to the loss of information. In other cases, non-response is also a consequence of the way the survey is designed. It can be due to the privacy concerns or due to the type of application, the language of the questionnaire, or the timing of the application. So there is a wide range of ways to understand non-response. And this is also connected to the complexity of the survey design. There is a trade-off between what we can control and what we can allow to be part of our methodology. Our aim in this webinar was not only to present the most important concepts on this topic, but also to inform of the impact of ignoring non-response in survey research. So now let's remember some of the key ideas we have learned in part 1 and 2 of this series of webinars. Here are some important concepts from part 1 of the webinar. Missing data can be classified as item or unit non-response. We know that unit non-response occurs when no survey data are collected for an element selected for the sample. The pattern of missing data we have studied so far were MCAR, MAR, and MNAR. And this pattern of missing data can also lead us to a better understanding of the ignorability of the non-response mechanism. We say that non-response is ignorable when the missing mechanism is MCAR or MAR. However, when the non-response mechanism depends on a variable of interest, measured between the same survey and observed only for part of the sample, the mechanism of missingness is MNAR and in consequence, non-ignorable. There is also 2 ways to classify the response models. One way is to group the participants based on their information, in respondents or non-respondents. This is a binary and deterministic way to classify them into 2 groups. However, there is also a stochastic model. The second approach is based on a response propensity model. And it's similar to a second phase of sampling. The only difference between 2-phase sampling is that in the stochastic model of response, the response probabilities are unknown and we have to estimate them. Well, we talk about a little bit of the important concepts, but let's actually see how non-response looks in a data set. The first ideal case is when we obtain information from all or sample participants, and is the first box, the ideal case, no missing data. The second box is item non-response, very common. We usually see this case in our data sets very often. What we actually do is to fill out in those blank boxes with information from the data available, often through an imputation method. Last, in our non-response case, in this data set, we observed that some participants did not answer to any of our questions, and in consequence, no information is available for them. This case, for example, the identification number 2, we have no information for this person in any of the variables. So what do you do in this case? Do you delete them or do you adjust the respondents to account for the non-respondents? Non-response rates in probability samples are increasing, said Lord 2016. And in most of the cases, our ability to link data and have some kind of information for the non-respondents group is also increasing. When we have information for non-respondents, we are able to work with some non-response adjustment to reduce non-response bias. So in this case, we will talk about adjusting for non-response in survey research. Broadly, imputation and weighting are the general approach used to adjust for non-response. Imputation is mainly used to adjust for item non-response. Imputation is the deliberate creation of data that were not actually collected. With weight adjustment, the non-respondents are delayed and the survey weights of respondents are adjusted to compensate for the non-respondents. In some situations, imputation is also an approach used to address unit non-response. Non-response is a common phenomenon in survey research, so a series of guidelines were written to address the topic. In this case, we are going to present the one that is closer to us. The Statistics Canada Quality Guidelines, Response and Non-Response, published in 2010. This guideline is grouped into 11 topics. Although they are all important, we will focus, or we will only focus on a broader view of them. The first 2 points are going to be addressed in the survey design stage to set a response rate and to ensure an acceptable level of quality in all survey planning and implementations. There are a series of steps that must be done. The guidelines also include a recommendation for the inclusion of follow-up of non-respondents that must be put in place during the data collection. The next group of topics are related to describing the respondents and non-respondents. The main approaches to adjust for non-response, as they said, are imputation and reweighting. And a non-response model will be developed to estimate unknown response probabilities. The last 2 topics are related to the quality of indicators, and is more so about post-survey analysis. Well, we know that when in the presence of unit non-response, we want to adjust for non-response. So up until now, we have learned that imputation and weighting are common approaches to adjust for non-response. However, how can we decide which general approach to use, and once they are selected, which tool to apply? To address this part, some questions should be answered before considering which one is the most effective approach. Can we assume the ignorability of the non-response mechanism? Are there meaningful differences between respondents and non-respondents? What are the claims we want to make from our results? If we classify our sample into stratas, how many respondents we have in each strata? Can we justify the use of one or another approach? Keep these questions in your mind for now. We will try to answer them or see if we can actually answer them in order to choose the appropriate adjustment for non-response tool. Let's go now to some information about using imputation to treat unit non-response. In this paper, published in 2012, Multiple Imputation for Unit Non-Response and Measurement Error defines imputation as an approach that involves filling missing values in variables using a selected imputation method and repeating the process multiple times. They describe that imputation is the deliberate creation of data that was not actually collected. When we think about weighting adjustment, a weight is created for the respondents to account for the non-respondents. So non-respondents are delayed, and the survey weights of respondents are adjusted to compensate for the non-respondents' information. In some ways, both approaches result in information we didn't collect, either imputation or weight. Well, let's continue with using imputation as an adjustment method for non-response presented in this paper. The key goal of his study was to demonstrate the ability to use multiple imputation to address for non-response. In his study, multiple imputation yield to lower variance estimates compared to those under weighting, but also lower variance estimates compared to complete case analysis. Remember complete case analysis from webinar part 1? Well, complete case analysis is the act of analyzing data only with the observed data and ignoring unit non-response. They also refer that multiple imputation could be impacted by the amount of missing data to a greater degree than weighting. So this paper is very interesting as he is comparing multiple imputation with weighting and complete case analysis. Pye 2007 also described another type of imputation, in this case, named hot deck imputation. In this case, he was referring at this tool that needs data from survey respondents, and in this case, the data from survey respondents is copied to represent data from a non-respondent who has similar characteristics to the respondents. In this case, we need sociodemographic data. Now let's go to the non-response line of research in the University of Glasgow. They also use imputation. In this case, we will see the non-response line of research led by Lindsay Gray. A collection of interest and particularly useful papers can be found from this group of research. And you can see the list here down in the bottom left of the screen in research team main publications. As she stated in this document, the importance of post hoc approaches, population-based health studies are critical resources for monitoring population health characteristics. However, reliable inference can be compromised by non-response that can reduce power and affect the generalizability of finding, especially when respondents and non-respondents differ significantly. So I find this paper, this publication very interesting, and also is very related to the work that they are doing, specifically related to health studies such as substance abuse and related conditions to it. The approach used for this group of research is a combination of record linkage and multiple imputation. Their strategy is very specific to their data characteristics and the country information they have. Their approach involves filling in the missing data in the survey in 3 stages, as we can see on this figure. In the stage 1, they use record-linked data between survey data and national data to determine the values for health outcomes for survey participants. Then, in the second stage, they made inferences on the non-participants by comparing the national health survey data with corresponding population data to identify their deviation from representativeness. In this stage, they create synthetic observations for the non-participants. In the stage 3, or the stage 3 in this case, consists in imputing alcohol consumptions for non-participants. In this stage, the unit non-response was converted into an item non-response problem, as they now have sociodemographic information and only lack information in the variable of interest. So in the stage number 3, they are using multiple imputation as they got the sociodemographic variables in the stage number 2 in the strategy that they built. Now let's move from imputation to weighting. In this case, weighting is the approach, the weighting approach is the opposite to the survey sampling process that we saw in early slides in webinar part 1. In this case, we will move from our final data set that contains respondents and non-respondents to represent our sample or to represent our population of interest. Weights are developed in a series of steps to account, as Frick and Caltons are describing, for unequal selection probabilities, non-response, non-coverage, and sampling fluctuations. When we build our weights, we can use auxiliary information that can be classified as design variables, variables used to the imputation or weighting, construct models, or variables for calibration or benchmark. Some covariate examples are age, ethnicity, gender, education, and more. weighting adjustment can be classified into class weighting and response propensity weighting. Also, the weighting approach can be classified as a sample weighting or population weighting. And after, a post-stratification or calibration can be done. For now, we are not going to get deep into each kind of weighting or the calculation of the weight. Let's just see how a variable that contains weights might look in our data set. In this case, we have a data set from SPSS and R, and we can see that weights are just a variable that contains a number that try to represent cases. In this slide, now let's compare weighting and imputation as a tool to adjust for non-response, trying to combine the both of them. In this paper, they compare multiple imputation and inverse propensity score weighting in unit non-response adjustment. They conclude that normally or generally multiple imputation yield to lower RMSE when auxiliary variables are strongly associated with the response. However, in the main idea of the paper and the main conclusion of the paper, multiple imputation is not consistently better than weighting or the inverse propensity score weighting. In this case, also, they explain that multiple imputation can require caution when generating global non-response weights, and it also requires more effort in model specification. But the benefit of multiple imputation is that it can handle item missing data in the auxiliary variables. And regarding to the propensity score weighting, the extreme weights result from the logistic regression they use. They also conclude that it can be addressed by the use of alternative methods such as generalized boost methods. And from that, or in that case, we want to talk a little bit of propensity score before we move to the GVM methods. But remember this last point in this paper from Alanya in 2015, that they are suggesting that a way to address the downsides of logistic regression can be the use of GVM estimations. So just remember that, but before, please, let's go to some conceptualizations of the propensity score. So we have been talking about response propensity weighting and the inverse propensity score weighting in the last slide. But we haven't really explained what is the propensity score. So to understand this concept, I would like to bring a paper titled "The Central Role of the Propensity Score in Observational Studies for Causal Effects," published in 1983. So let's begin with the propensity score. They define propensity score as the conditional probability of assignment to a particular treatment given a vector of observed covariates. Just think about our non-response response group as treatment assigned. For example, instead of groups of treatment and control, we can think about respondents and non-respondents. So in that case, the propensity score is the conditional probability of assignment to a particular treatment given a vector of observed covariates. In this paper, they are focusing on the idea of causal effect that comes from the experimental design. That's why they are talking about a treatment or a particular treatment given a vector of observed covariates. So in that case, just try to remember a little bit the difference between the experimental design, that in that case, experimental designs allow causal inference. The main goal of the randomization that is included in the experimental designs is to balance the groups so we can compare them. But in observational studies, we don't have control on the group's sociodemographic background. So for that, propensity score can be calculated based on the covariates or the ancillary data to balance the groups and allow us to compare them. Remember the ancillary data from webinar part 1? That are data that we can get from another data set or from another source of information. So the propensity score in this case are then calculated based on that ancillary data to balance the groups and allow us then to compare or to make comparison. Let's move now to two terms that we are going to be using when working with the propensity score. First is the ATE, the average treatment effect, that measures the difference in average outcomes between units assigned to the treatment or units assigned to the control. The ATE is the average at the population level. Then a second related concept is the ATT. The ATT is the average effect of treatment on those subjects who ultimately receive the treatment. And then another point that is very important from this paper are the assumptions that should be met for the PS to work. The first one is a treatment assignment that is strongly ignorable. If the probability of a unit receiving a treatment is when the probability of a unit receiving a treatment is strictly between 0 and 1. And the stable unit treatment value assumption involves assuming that treatment applied to one unit do not affect the outcome of the other unit. So from this paper, all that I want you to get is the idea that the propensity score comes from the studies for causal effects. That we have the propensity score, that is the conditional probability of assignment to a particular treatment given a vector of observed covariates. What we try to do is to balance the groups so we can compare them, because in observational studies, we can't actually control the sociodemographic background or variables from our respondents and non-respondents. So now that we read a little bit or that we talk a little bit about the propensity score in how the idea was initiated, let us now see some of the conceptualizations more related to our example. As we can see in the first two concepts, a propensity score is the conditional probability for an individual to be assigned to a grouping condition. Response propensity are latent variables, and all we can observe in our data set is the binary classification of groups in respondents and non-respondents. Propensity score is often used to match data, subclassify, or for weighting. Propensity score was described by Alania 2015, as the commonplace and popular model-based technique for adjusting for non-response. It consists in modeling the probability of the response indicator and then assigning each respondent a weight that is the inverse of his estimated propensity score. Remember that idea, that is the inverse of the estimated propensity score. One of the advantages of working with propensity score is that it takes information from each participant, depending on the participant conditional probability. And the final weights that we get are used in outcome analysis on the respondent's portion of the sample. So here are two ideas that I want you to remember, that this takes a differential amount of information from each participant. and that the analysis or the outcome analysis is actually done on the respondent portion of the sample. Propensity score weighting can be done in some steps. Here, we have that the first step is estimating the propensity score, and that can be through logistic regression, as we see in some of the paper presented in the previous slides, or it can be done through the GBM models. Then we calculate the weights. It can be the ATE or the ATT weight, and then we specify the weight in an outcome analysis, or we use those weights in our outcome analysis. Parametric and non-parametric methods can be used. Gell in 2018 described that non-parametric methods are preferred. Logistic regression is an example of a parametric method that might not be robust to model misspecification. So, due to the downsides of logistic regression, a machine learning technique was imposed. So, to overcome some of the downsides of logistic regression, the use of machine learning algorithms is being proposed. In this case, we talk about the generalized boosted models. This GBM estimation involves an iterative process with multiple regression trees. GBM works with larger number of continuous or discrete covariates. In this presentation, we will be using the propensity score package TWAM. This package was developed in 2004 to support causal modeling of observational data by evaluating propensity score and associated weights. And it was also used in education, policing and criminal justice, drug treatment evaluation, and military workforce. The propensity score weighting aims to reduce bias by weighting complete cases with non-response weights and making them look like the entire sample. And this is done in 3 stages. We compute the propensity score weighting, then we check the quality of the balance, and then we use those weights into an outcome analysis. The propensity score weighting that we are going to implement in this presentation is easy to use, and the combination of non-response weight that we get from it and sampling weight is valid, and as they are both probability weights, they can be multiplied by. So now let's do some demonstration of the propensity score weighting estimation. We use simulated data to compare results of complete case analysis versus weighted analysis. We will demonstrate the use of logistic regression and propensity score weighting for estimating survey weights to answer some questions. We focus on the estimation of a population mean and on a continuous variable. We have a data set containing 8,717 participants, and our variable of interest is mental. Remember in our webinar part 1 that we explain an example. So this demonstration comes from that idea. So in this case, our outcome variable is mental, and then we have a binary unit response indicator that classifies respondents into 1 and non-respondents into 0. We have 4 auxiliary variables: sex or gender, age category, confidence in health providers, and number of hospital visits. We begin by estimating the weights using logistic regression in IBM SPSS, and we also include some descriptive statistics. As a second step, we calculate the ATE weights in the package Twang in R, and also some descriptive statistics using the weights. The software syntax for each approach is attached to this presentation, and a video demonstration is also included. Let's begin with some explanation of this tutorial. For the demonstration of propensity score weighting in logistic regression, I would like you to situate the folder unit non-response into your library C. Inside the folder unit non-response, you are going to find another subfolder named demo.lg, and inside this folder, you are going to find a data set and the SPSS syntax. Once you open the SPSS syntax, you will open the data set, estimate the predicted probabilities with logistic regression, calculate the inverse of the predicted probability, and then create a new data set that will contain only the participants who respond to the survey and their weights. And then you can use the SPSS complex sample analysis to continue with your outcome analysis. In the demonstration of the propensity score weighting with the Twang package, you will follow almost the same steps. You will locate your unit non-response folder in your directory C. You will open the subfolder demo Twang, in where you are going to find a data set and an R code. And once you are in RStudio, you will set your working directory, install package, import data sets, estimate the ATE weights with the PS function of this package Twang. You are going to evaluate the balance of the weighted and unweighted sample. Then you are going to create a new data set that will contain only the participants who responded to the survey and their associated weights for non-response. And you are going to use this data set for outcome analysis using the survey package in R. Don't worry if all these steps sounds like a little bit confusing, because you are going to have a video that explains each of them. Now let's just see how you're going to locate the unit non-response folder in your directory C. Inside that folder, you are going to find two different subfolders. In the subfolder demo.lg, you are going to find a data set and a syntax file. And in the demo Twang, the same. You are going to find a data set and an R code that you have to open in your RStudio. Now, please go and see the videos for the calculation of the propensity score weighting using logistic regression and GVM in Twang. Welcome back. I hope that running the analysis was easy for you and that we both yield to the same results. If you didn't, please just keep trying, try to follow each of the steps in the syntax or the R code that you are going to get to the same results. Let us now look at the results. In this case, we simply estimate the population means in three different cases. The first one is the complete case analysis, which is ignoring unit non-response. We only work with the observed data. The second one is using the weights that we calculate from the logistic or with the logistic regression. And the third one is using the weights that we calculate with the Twang package through the GVM estimation. As we can see, as soon as we include weights that accounts for non-response or mean in mental, in our outcome variable, is a little bit lower than the complete case analysis. That it looks like the complete case analysis is inflating the mean of mental. So let's go to some conclusions from this demonstration. In the first topic, waiting for non-response, we say that it's also analogous to the role of sampling weights, as Little and Bartivarian 2005 remark. Non-response weights can be used with sampling design weights. As we have explained, it is not invalid to incorporate the two types of weights into one by multiplying them. Is a non-response ignorable or not ignorable? Well, knowing our non-respondents' information is not always feasible. However, now or nowadays, data linkage can allow us to connect non-respondents' information to different data sets that might contain sociodemographic information that can allow us to explore the difference between the respondents and non-respondents. Testing for non-response mechanisms is still a hard approach to do, as we not often have the certainty that all variables that are related to the response or non-response mechanisms are the variables included in our data set. What we know about our respondents groups is now more important than ever, and it can allow us to stop ignoring non-response and start building response or non-response models. As we specified in some part of the webinar, when working with cells, it's particularly important to count or to count with enough information of every type of subclassification. And each cell should at least have a minimum number of cases. And that is not always feasible to achieve. So working with propensity scores weighting into an individual score or weight is probably an easy way to approach unit non-response. Well, the literature review has shown to us that nowadays machine learning approaches are preferred over logistic regression. However, most of the literature in propensity score weighting includes logistic regression as an approach to calculate the propensity scores. In our study, both GVM and logistic regressions yield to the same or the similar outcomes. Well, the statistic classification of respondents and non-respondents is a static view of response models. The propensity to respond to a survey is more stochastic and varies across surveys, topics, and context of research, and is very, very connected to the sociodemographic variables. To calculate our outcome analysis, we only work with the set of respondents that represent the portion of the non-respondents. So in this case, we were not filling into the blank boxes, but including the respondents and their non-response weights into the analysis. To calculate the propensity score weighting, we use two different softwares that allow our audience to work with the software that they feel more comfortable with. So up until now, we learned that there are two main approaches to adjust for unit non-response. We have imputation and we have weighting. Usually imputation is more used for item non-response and weighting is more used for unit non-response. We also know that we need ancillary data to adjust or to make the adjustment. And we also discover or understand from webinar part 2 and also here that complete case analysis is not the best option when in the presence of unit non-response. We have to start taking into account the presence of unit non-response and try to adjust for it. So now I would like to talk about that unit non-response is a complex phenomenon that is increasing. And we cannot really ignore and simply work with complete case analysis, expecting that our results will be free from bias, resulting from the difference between respondents and non-respondents. So to understand and conceptualize unit non-response, let us now see the following framework. This ecological model of item and testing responding was presented as a part of my doctoral dissertation in 2018 and is highly inspired by Dr. Bruno Zumbo's line of research. As you can see down in the screen, there are two of the most important papers from him and his research team. In this case, the ecological model presented in this webinar, it's only one instantiation of the multiple ones that can be built depending on the area of work that we are focused on. It can be in health measurement, it can be in educational, or in any order. As its name also stated, it's ecological as it includes information from various sources that are related to the participant. The survey research design, the measurement characteristics, and the context in where the participant is situated. Or in words from Dr. Zumbo, the ecology of the testing situation. In this case, more specifically, the survey situation. In contrast to Bruno Zumbo's ecological model, the model presented here is not only interconnected, but also embedded, as most of the characteristics are in relationship with each other. Let's now unpack this model. We say that the participation or not participation, or as well the questionnaire, survey, or item response is related to the participants' intrinsic characteristics. And here we can include some of the examples from our webinar part 1, such as the participant psychological characteristics or the ability to respond to the survey. Then, the participant context, that can be his family and the values they share based on their own experience in life. A third ingredient to this view of participation or non-participation is the community in where participants belongs to and its background characteristics. The participant is not only part of a community, but also is in a bigger picture or is part of a system that promotes certain actions and values. Another ingredient that can be related to the willingness to participate is the relationship or experience they have or had when in contact with health providers, in this case, in a health context. Behind the decision to participate or not, it's a cost-benefit analysis that underlines the process. And that analysis is highly informed by the sense of community, responsibility, and commitment that the participant has to the improvement of the services evaluated. So now, up until now, we were talking about the survey. We were not talking about the survey yet. All we include were the context in where our participant is immersed. Now, let's move a little bit to our survey design. As we explained before, survey design characteristics could be influencing the inclusion or not of non-respondents due to, for example, confidentiality statements or the way or the moment in where the survey was applied. Then we have the measurement design. The construct evaluated as well as the response process are important ingredients that influence the willingness to participate or not in a survey. So all of this, and probably even more of other characteristics, are mechanisms that underline the participant's decision to engage in a survey. And as the total survey error model stated, there is a close relationship between measurement and representativeness. And in this case, I would like to add that there is also an influence from the participants' close context that influence the process of responding or not to our survey. The model presented is only one instantiation of an ecological way to understand item and test response from an embedded, multi-level, and multi-source point of view. Well, now we finished the part 1 and part 2 and part 3 of this series of interconnected webinars, and I hope that the information that you find in all of those presentations are actually helpful for your work. The whole webinar series was prepared to help data analysts and practitioners to understand how missing data might complicate interpretation and analysis, or how that can distort our conclusions, and to introduce a framework to understand the phenomenon of unit non-response. Thank you so much.